Morning. Thank you for taking time out of your Thursday morning to join us for what promises to be an excellent webinar. I'm Stuart Foster, RECOUP CEO and Chair for today's session. The session is titled Addressing the Needs and Challenges for Reusable Packaging Systems through Digitalisation, Learning from Project TRACE. Just to get it out there from the start, TRACE stands for Technology-Enabled Reusable Assets for a Circular Economy. Got to have a good acronym for a resource project these days. We've got a fantastic lineup of speakers taken from the project team of this UKRI Smart Sustainable Plastic Packaging Challenge Fund initiative. That includes Pragmatic, the University of Sheffield, AMRC, Cymru and RECOUP. The aim over the next hour and a half is to share with you the learnings, but also the challenges from across the different elements of the project and give you a chance to ask questions as well. In terms of the Zoom system, delegates are muted and videos are off. If you want to ask any questions, you should find at the bottom somewhere there is a Q&A box, so please do pop your questions in there during the presentations, and we'll pick them up either as we go, or there is also a Q&A session at the end of the presentations as well. We will be recording the webinar, which is going to be shared afterwards with a copy of the slides as well. Since you're on this webinar, you're probably well aware that reuse has actually been around as a concept and development area for a while now. But even since the TRACE project started, the pressure and the focus on reuse to work effectively and at scale has increased. Packaging reuse and refill are recognised and accepted as pieces of that circular economy jigsaw, alongside recycle and reduce, of course. But I think it's fair to say there's still a lot of work to be done to understand, innovate and deliver on that requirement across all parts of the supply chain, both from a cost and from a system perspective. And we really need to truly realise those benefits and bring packaging reuse systems into the mainstream, ensuring that they're accepted and then used, and actually used by the many and not the few. So we've got lots to get through. That's enough from me, and I'm very pleased to introduce our first speaker, who is Emma Kastrasiniaki-Guyton from Pragmatic. Emma, hope you're there. Over to you.
Thank you very much. Just one moment, please. Okay, good morning everyone, and thank you to RECOUP for the introduction and for hosting this webinar. As Stuart said, we're going to be talking all about TRACE and I suppose what the project's been about and what we can kind of take away from it. So my name's Emma. I am a project manager at Pragmatic Semiconductor. We are a semiconductor company based in Cambridge. And really what I want to do for the kind of initial part of this webinar is just to give a bit more context really about what the TRACE project's been about, what are some of the challenges we want to kind of address, or we wanted to address going into this project. And I suppose give a bit of a flavour so that the speakers later can then talk about their individual work packages and some of the more specific learnings, let's say. So that's the plan for the next kind of couple of minutes. So TRACE, as Stuart said, it's a UKRI funded project through the Smart Sustainable Plastic Packaging Grant. And it's been going now about 2.5 years. We're just wrapping up at the end of this month. And basically we are looking at how can we address the challenges, or some of the challenges, of scaling reusable packaging via the use of digital technologies. So specifically, we've been looking at food packaging because of the kind of huge challenges there around sort of grocery packaging in terms of volumes of packaging, in terms of the number of different kind of SKUs, all kinds of different things. And really looking at what can we achieve by adding something digital to the mix. So the project partners you can see at the bottom, most of those are speaking today, so you get a chance to kind of hear all about what they've been up to for the last 2.5 years. So I suppose for a little bit of background, what I want to just cover is some of the challenges that we we see in terms of scaling reuse. I'm sure many of these will be familiar to a lot of people on the call. And then start to go into kind of, I suppose, why use digital at all, and what we feel that digital technologies can bring. So in terms of some of the challenges, so first we have the kind of consumer side engagement, making sure consumers are kind of buy in on the journey, making sure they purchase the reusable packaging kind of option, making sure they return in a timely manner, making sure they're engaged, making sure it's a kind of positive experience and that they want to then do that again. We also have the sort of economic side, so the sort of business benefits. So a lot of times these types of systems, they struggle to scale because of this factor, because of the challenges in cost. So what can we do in terms of adding something digital to really kind of improve efficiencies, to understand the system a bit better, and then start to optimize? And lastly, sort of environmentally, we want to make sure that by having a system like this, it is in fact beneficial from an environmental standpoint when compared to a single-use alternative from various different aspects. So looking at, for example, emissions, looking at material use. So how can we kind of track the system to really make sure we are breaking even in terms of our kind of environmental footprint? So all of these things are really, really challenging. And we think really need a lot of data to be able to kind of really overcome them at scale. So when we say data, we are basically talking about every individual item of packaging having a unique ID, a unique identifier to it, which can then enable it to be traced through the system and can kind of bring some of those consumer benefits as well. So what I wanted to do, just so everyone's on the same page, is just cover a little bit about the technology side and essentially what types of technology might we see in reusable systems, and where are we focusing, basically. So what we've done here is just kind of map the most common technologies on this sort of engagement automation scale, if you like. So it's a kind of rough guide as a sort of visual. So on the left-hand side, we have that kind of consumer engagement technology where it's much more on the consumer side for that kind of individual communication, let's say, with the consumer. And on the right-hand side, more of the business, let's say, automation, supply chain type benefit. So if we start on the left, we have QR codes, which I'm sure everybody on the call will be familiar with. So QR code, QR stands for quick response. It's a two-dimensional kind of optically scanned code. So as a consumer, you open your camera, you scan that code, but you can also kind of scan that in a more industrial setting. That brings some challenges because codes have to be scanned individually, and also they're obviously kind of optical, so you need the right lighting and you need that code not to be tampered with or damaged. If we move over to the very right-hand side, we start to think about RFID, so radio frequency identification. By that, I mean ultra frequency RFID, which is the type that I suppose people most commonly think of as RFID. So that's the type that you would see in a kind of supply chain setting, in a sort of automated checkout setting, where every item has a physical tag, and that is read by a scanner. Now, the scanner is a sort of dedicated scanner, not a smartphone, but you can read from a pretty long distance, so quite some meters. You can read many items at once. So really, that's for that sort of kind of back-end type benefit. So the business side doesn't interact with the consumer. And in the middle, we've got near-field communications, NFC, which is actually a type of RFID that uses a different frequency. And that protocol is supported by most smartphones. So what that means is that it can be scanned by a consumer, but it can also be scanned by these types of industrial readers. Now, I suppose the difference with RFID and NFC particularly is the read range. So you need a much closer read range, seem to be much closer to the tag in order to be able to read it. But it does give you that kind of dual benefit of the consumer side and this kind of more automated angle. So really that's where we focus, is that middle piece, because of this need to kind of bring together that consumer engagement piece with the business benefits. And I wanted to spend some time just kind of outlining basically these terms, because we'll talk a lot about NFC and we'll also talk a lot about RFID on the call. Generally, we are talking about NFC, but just bear in mind it is a type of RFID. The actual tag is very, very similar. And it's kind of, in terms of the actual footprint on the packaging, it's the same basically. But we will be using the terms basically interchangeably. Okay, so what I want to do then is, I've got a very short video. Mainly it's just to illustrate what this type of tag looks like and how we might visualize it on the packaging. So hopefully this works. So if I just pause there. This is a video that's showing an RFID or NFC tag basically on a coffee cup. What you can see around the sort of circular piece, that metallic piece, is the antenna. And generally, I suppose you wouldn't have it on the outside in quite this way. As RECOUP we're going to talk about, there's different ways of kind of including that in packaging, but this is mainly a visual aid. So if I keep going, what I want to show is basically, so this whole metal piece is the antenna, and then here, this little piece is the integrated circuit, so the semiconductor chip, and that is what we make Pragmatic. And basically, Pragmatic, we make this in a completely new way out of new materials. And what that means is that we have a much lower kind of carbon footprint of manufacture, much less water needed. It's also lower cost and kind of physically flexible. Now, I suppose all of those benefits lead to it being, we think, a kind of good fit for packaging and for particularly these kinds of sustainability applications. And we're also kind of, I suppose we've got sustainability in the kind of backbone of the company. So we're really interested in how we can enable these types of application. And I wanted to show that just to kind of show, I suppose, what the different components are of the technology. So just to kind of recap then, we're looking at NFC for reuse particularly. And that is because of these kinds of benefits from the consumer side. So you can have that kind of consumer engagement angle, but also the item level traceability. So each of these RFID tags, the chip has a unique ID that can be read at various different points of the reuse cycle to kind of keep track of essentially this large volume of reusable packaging. And it also enables this kind of automated side of the reuse cycle. So for example, we can think about returns. If we are looking for that level kind of return to store type model, we can do that in quite an automated way. So for example, this type of smart bin that you can see in the image, you can embed a reader within that bin so that you kind of can automate the return. So as soon as a consumer returns, that is then registered in the system. So there's a lot of different benefits that we've looked at here. So I suppose that's essentially what I wanted to cover, just to kind of give that background. Trace itself has looked at many different kind of components of the reuse system. So we've looked at so packaging and system design. So this is led by RECOUP, which Irena's going to be talking about. So really, I suppose, how can we incorporate these types of technology into reusable packaging? And also in general, what is best practice really for reusable packaging in terms of the items, in terms of the system? We also have the consumer perception side, so the sort of psychology angle that the University of Sheffield has been working on, which is going to be talked about by Tom, looking at these sort of what their studies have shown in terms of the consumer concerns, barriers to uptake, etc., and what we can kind of learn from that going forward. We then have the AMRC team looking at the sorting. So they've developed a sort of physical demonstrator of a sorting system, which uses this kind of scanning the NFC tags to then kind of register an item and then divert it to the particular part of the sorting of the area. And that's really important because if we think about, you know, a materials recycling facility today, typically things are sorted by the type of plastic it is, let's say. And what we want to do is start to think about how we can sort by perhaps what the item is used for, or the shape, the kind of form of it. Because you can imagine there's many different types of packaging that you'd want to sort differently that are all made from the same materials. And then lastly, looking at the environmental impact. So that has been led by Ashik here at Pragmatic, thinking about then if we add this type of technology, so we add an RFID or an NFC tag, what impact does it have on the end of life? So when the reusable packaging reaches its kind of natural end of life, when it's been used many times, does that RFID tag have an impact on the recyclability? And he's also been looking at the sort of the entire reuse system. Where are the sort of emissions hotspots, let's say, and other kind of environmental analysis. So that's basically what we're going to cover today. And that is what I wanted to kind of talk through. So I'll be obviously sticking around for till the end for questions, but otherwise I will hand back to Stuart. Thank you.
Thanks, Emma. And yeah, just a reminder to the audience, if you do have any questions, just pop them in the Q&A box. Emma, just before you switch your camera off again, of course, the start of this project wasn't the start of the reuse journey for Pragmatic. How kind of long have you been working on reuse and solutions?
Yeah, I mean, so we've done a number of projects, really. So there was a previous project looking at the sorting angle with the AMRC. We've looked at deposit return schemes as part of a previous Innovate UK project called Sprite. So yeah, we've done it for, I mean, I've been with the company just over 2 years. It's certainly longer than that. So yeah, quite some years.
Lovely. Thanks, Emma. And I know you'll be back later for the Q&A. So yeah, much appreciated and great introduction to the project.
Thank you.
So we shall move straight on. The next speaker is Irina Ankadanova from RECOUP. Irina, over to you.
Good morning, everyone. Just sharing my screen. Okay, did it work? No? Yep. Okay, good morning, everyone. Thank you so much for joining us today for this webinar. Thank you, Emma, for introduction. And I'll be talking today about the reusability by design. RECOUP was leading the work on reusable packaging design for the project Trace. Okay, just a moment. Okay, next. So RECOUP is UK leading authority and trusted voice in plastic resource efficiency and recycling. We are charity and we are a member-based organization working with our members to increase plastic circularity. We cover areas as a policy and infrastructure, packaging recyclability and design, citizen communication, LCAs, and reuse systems. As part of the project Trace, we developed the reusability by design guidance for the reusable packaging. For the reusable packaging to fulfill its function to the maximum environmental and economic benefit, it needs to be designed with a systemic approach and taking all the stakeholders' needs in consideration. To assist with this, we conducted desk-based research and also did the survey of the value chain, including packaging manufacturers, packers, fillers, brands, retailers, consumers, service providers, for example, cleaning or logistics providers, and waste management companies to understand their views, which was also followed by the reusable packaging design workshops, interviews with industry representatives, and some of the laboratory tests conducted by University of Sheffield. The aim of this document was not to create a strict list of rules how the packaging needs to be designed, but the underline and highlight the areas where the most attention is needed, and in particular where this collaboration between different stakeholders and value chain players are needed. So this guidance is available on our website, and we identified the key areas for the design, and it covers durability and material choice, decoration and branding, consumer needs, traceability and tracking, environmental impact of reusable packaging, food safety, standardization, among others. The materials choice is probably the first and most influential decision in the reusable packaging design. Currently, represented materials are leading with plastics, followed by metal and glass, with some of the representation of paper and other novel materials for the reusable packaging. On your left, you see the diagram with the survey responses for the materials or the polymers. It is because Project Trace was focusing on the plastic reusable rigid packaging. And to further our research, we picked up 5 polymers, PET, PP, and PE, as it is widely represented in single-use formats. And we also wanted to explore Triton and PBT, as there was interest if there is a need for the reusable packaging in different polymers which can offer additional properties, if this can help with adoption of the reusable packaging. You can see, interestingly, that the PET leading with 30% of respondents seeing it as a suitable polymer for the reusable packaging. Well, we heard a bit different from the workshops and conversation, and also if we look at the representation of the polymers among the reusable packaging, it's usually PP. But from the comments, we know that the PET is recognized as the material for the drink systems established, for example, in Germany and Americas, and also the presence of established food-grade recycling route for PET is important factor. On the right, there is top design priorities identified as part of our research. We can see recyclability surprisingly taking a lead, like while we all want the reusable packaging to stay in circulation as long as possible, it's still good to see the desire to get the material circularity seriously from the beginning. The durability is second, which is one of the distinctive features consumers in retail expect from the reusable packaging. At the same time, it is important that reusable packaging not over-engineered, because we know that in a very well-established systems, it's already go over 95% reuse rate, which is just 20 reuses, and it's need to take into consideration. Cleaning, logistics, production lines, brand information, traceability, that's all important functionality and recognized by the value chain representatives. And here we can see that the visual appearance is much less important for the reusable packaging. It needs to do its job right. In terms of the packaging format, it was communicated that the reusable packaging shouldn't be very much different from the single-use formats. It needs to be easy to communicate to the consumers that it performs the same function. Even more importantly, they will allow reusable packaging to fill existing infrastructures such as filling lines and packing equipment. Size and shape, also the key consideration for the washing phase. The packaging needs to be easy to clean. It needs to maximize the washing facilities capacity, and also be easily transported to the washing due to shape and size. Also avoiding the elements which can accumulate potential water or bacteria, important consideration for the shape. As part of the research, the University of Sheffield conducted washing durability testing for the number of samples of single-use and reusable packaging. All the polymers were represented, and even in single-use format, the good news is that after 20 washes, most of the packaging still didn't show any significant changes. they did maintain the wash through the wash. There was only some small expected changes through the thin-walled PET samples, but again, they were not designed for the washing. It was noted that the elements as ridges, for example, can add extra stability, so this can be mitigated. Standardized, durable, reusable packaging, which is used across the brands, probably a marketing department nightmare. It was widely commented that decoration and branding is important, not only for the consumer engagement, but because it often brings important information, such as product details, recycling information, storage instructions. For the reusable packaging, it was agreed that the probably temporary solution, which can last one cycle and then easily removed to the wash, is the most optimal. Or also commented that all the decoration and branding elements need to be recyclable. And obviously, reusable packaging, we expect the branding and decoration to be agile, in some ways innovative. The picture here on the slide shows it, for example, for the Coca-Cola bottle, even without any labels, the shape is so recognizable that it works as a branding. That could be some exploration for the reusable packaging. How can we brand without additional tools to keep the material use at minimum? Branding is vital. It needs to be removable, agile, and innovative. Even the well-designed system doesn't make sense if the consumer are not using it. And here, as in many other places, the balance is a key. Consumers want attractive, pleasant to use, and novel packaging. At the same time, not too beautiful, so people keep it at their house and don't want to return it, stopping the system from the functioning. Clean and new, that was very important, and that's through the design. It can be mitigated by the right choice of the polymer or of the material, right finish, experiment with colors, depending on what product will be served by the packaging. Ergonomic and inclusive, especially when we talk about digitalisation and tech aspects. How do we make packaging inclusive for people who don't want or cannot use the technology? What alternative we can offer them? Easy and quick to use and return, especially if the consumer involved in the refill procedure themselves. It is expected to not cost extra and don't be any extra effort, and easy to store and transport, such as stackable or foldable formats. It was said that its customers are ready to use reusable packaging. There is an element of delight, but obviously it needs to be easy to use and functional. Digitalisation is a recognized trend in the industry, and it's expected most of the packaging will have some kind of the technology associated with them in the future. It provides many benefits to the reuse system, such as communicating number of reuses, monitoring where packaging was borrowed and returned, more importantly, where packaging was used, what product it was used, and what cleaning procedure the packaging went through. This can help mitigate the challenges associated with food hygiene and allergy risks if we can use this information provided by digitalisation. As part of the design, there's various ways to apply digital technology to the packaging. And on a diagram, you can see that there's some of the application can be printed on the packaging. There is an option to be applied through the label for RFID, for QR codes, for the barcodes, for the digital watermarks. Digital assets can be embedded in the packaging, engraved on the packaging, and also there's exploration of including the asset as part of the removable part of the packaging or overmolding. So all of them make sense and useful depending on the packaging application. Label is agile form of labeling of application, allowing asset to be removed if it's non-functioning or at the end of the life to ease recycling. Embedded application is more suitable when the tag only used by the system for system efficiencies, and the consumer as such doesn't need to interact with the technology. As part of the reusability by design guidance, University of Sheffield did an overview of how tracking technologies have been used within reuse system, which is available as part of the document as well. There was also some test on the durability of application tracking technology through the labels. So what we tested all 5 polymers listed previously with 3 types of adhesives through 30 wash cycles. All of the polymers, all of the adhesives, acrylic-based, rubber-based, and food grade, which can be important for the food grade systems, maintained the adhesion. Was no pilling recorded for the round tags, so that shows that the system is quite durable for the intended application. We also tested the tags on curved surfaces, which is a bit more challenging than on a flat surface, but at the same time, when we can see a small area where the elements can penetrate, the tag still stayed on the packaging. So it's better to avoid curved surfaces and ridges. However, there's still good adhesion and very secure attachment of the tags to the packaging. Recyclability design consideration is, as we discussed, important for the reusable packaging. To design reusable packaging to be recyclable is the same principles of what apply to the single use. It's preference for the mono-material, preference for the material with established recycling route. If there is elements of closure or labeling, that needs to be either easily removable or recyclable. There are some perceived recyclability challenges for the reusable packaging if it enters the waste stream in the big numbers, which weight durability, if it's too heavy, over-engineered, it can be different to follow the material recycling facility flow. Wear and staining potentially can affect, but that needs to be more investigated. Ashik will be speaking later about recyclability of technological assets, what always raised as a question in relation with reusable packaging equipped with the tech assets. But a part of the challenge, there is a great opportunity for reusable packaging due to its increased traceability. All these benefits that tracing technology can offer, knowing what was in the packaging, what was the packaging journey, create the great opportunity for this packaging to be captured, to be closed loop food grade system with a high recycling, with a high potential to be used on a same application. We have 4 documents coming soon, so the update for the reusability by design, overview of the technical guidance, summary of the reusability by design, and RFID-enabled packaging case studies, which will all be available at the RECOUP website at the end of the project. Thank you so much. If you have any questions, please feel free to contact me or Catherine.
Lovely. Thank you very much, Irina, for that. Just as a reminder to the audience, yeah, the slides will definitely be shared after the webinar, so you'll get a copy of those. Okay, so Irina, there's a few specific questions for you that have cropped up. So can you just confirm, in terms of that survey that you mentioned, in terms of importance, was that consumer or industry partners?
That was the survey was initially kind of aided at the value chain. So we asked representative of the industry. However, we found that quite a lot of survey respondents still identify themselves as consumers. So there is a variety of responses ranging from all the industry and consumers.
Lovely, thank you. And another one recognises that traceability was quite low on that list. And they were curious to know the splits on that. And a sub question from me actually is, I know the project has been going for a while. When did you actually do that survey? And do you think maybe if we did it again now, maybe some of the answers might change?
I just wanted to bring the attention in this diagram, the traceability, like the percentage is of responses would identify traceability as extremely important. So if we look at the whole picture, all of these design considerations on the list were really identified as important or just moderately important by the respondents. So there is just the range, but it's still seen as very important. The survey was conducted at the beginning of the project, so around probably two years ago. And it was from the feedback and from the comments, even back then, we could see that traceability was seen as a solution for some of the challenges, for example, in food safety, for example, in environmental impact, to understand the system efficiencies. So we cannot see that there was kind of something saying that traceability is not important. It is definitely a big part of the reuse system.
Lovely, thank you. I know there's a question around LCAs, which I know is coming up later, and I can see Ashik is adding a couple of answers to that as well. So we'll pick up the LCA question later on in the session. Also, there's a question around RFID tags and which I think with AMRC as well later on. Yeah, I'm just looking through it. I think some of these other questions I'd actually like to bring out a bit more within the discussion at the end. So there is one other question within the value chain. Were some of the audience category managers?
Pardon?
So in terms of the value chain, within the value chain, if some of the audience for the questions were specific category managers, I guess within brands, or do you have a breakdown of the kind of people responding to our survey from those companies?
Yeah, we did have quite a variety of representatives from the brands and from retailer and from category managers, and it was various representations. So some, like in brands and retailers, was represented quite well. So with a very, like, that's why we have such an emphasis of decoration and branding and marketing as such. We have when we were analyzing the result of the survey, we looked at the splits for different representatives from, like, and there was a variety of responses from the waste management, for example, and packaging manufacturers and retailers. However, the difference was not that significant between the different sectors. I think that's due to people talking to each other and understanding the value chain. So I think probably the most difference we notice in some of the consumer questions or other, but in general, the trends were very similar for kind of different categories. And I also can take questions about RFID and VEE, because we clarified it in our guidance. If the technology applied to the reusable packaging assets, it's not falling under the regulation for waste electrical equipment. So it's not considered under the kind of item that needs to be disposed separately.
Irina, thank you. For those asking questions, we've not forgotten you. We'll hopefully answer some of them as we go through and pick others up at the end. But yeah, thank you, Irina, for that. And we should move on. So one of the things that came out from Irina's presentation is the consumer. And until such time that people design a system that doesn't need the consumer involved, they're a very, very important part of whatever solution comes through. Very pleased to have with us Professor Tom Webb from University of Sheffield, who's going to talk us through some of the issues for consumers and strategies for increasing engagement. Over to you, Tom.
Thank you, Stuart. Good morning, everybody. So I'm a psychologist at the University of Sheffield, and I worked on the TRACE project alongside two researchers, Megan Matthews and Artemi Tonikidou, with the guidance as well of Sarah Greenwood. So our part of the TRACE project, as Stuart said, focuses on the people, and specifically the consumers that engage, or as many of us know, more commonly do not engage with reuse systems. So it goes without saying, but I'm going to say it anyway, that people are central to the success of reuse systems. Reusable packaging for consumer goods is only going to have a positive effect on environmental outcomes relative to single-use alternatives if consumers are willing, able, and do buy products in reusable packaging, and then also complete the other associated actions like return that packaging so that it can be used again. So what we wanted to do within the TRACE project is look at what kind of factors influence consumers' engagement with reuse systems, specifically those supported by digital technology. So the first few pieces of work that I'm going to tell you about today are described in a paper that Megan and I published in the journal Sustainability. It's free to access, so please do take a look if you'd like more information. I can provide a link, or if you just Google the title, Understanding Consumers' Willingness to Engage with Digital Reuse Systems, you'll hopefully find it. So in our first study, we recruited consumers and we showed them a series of scenarios. Each of them described a context in which containers and packaging might be reused. So things like dry goods delivered to homes, dry goods purchased in store, like by store I mean supermarkets, grab and go bottled drinks, when you're on the move, and so on. And different systems for reusing those containers. So systems, the example on the screen here is where you would return the reusable container to a delivery driver. But there were other ones where, you might return it to store alternatively. And each of the scenarios specified that the containers have a digital chip within them, like that described by Emma. So one of these RFID tags. And that enables the system to know whether the container's with a customer, in a washing facility, ready to be refilled for the next customer, and so on. And then following each, so participants read about the scenario, and following each scenario, they completed a number of open-ended questions. How easy or difficult would they find engaging in these behaviours? If they had any concerns about reusing containers, and what advantages and disadvantages they associate with this sort of system. And Megan went through all of the responses and coded them thematically to compile a list of factors that could potentially influence consumers' uptake and use of digital systems. So identifying a number of barriers and a number of things that would enable people to use systems. I'm not going to go through these in detail now. We don't have a great deal of time, but do have a look at our paper. There's a discussion of each of these factors. One of the key issues I want to draw our attention to and focus on for the next part of the webinar is that one of the issues for consumers that was specific to a digital reuse system is that people had concerns over the tracking element. They felt like tracking containers is intrusive and that potentially their security would be compromised by tracking the container. But this concern over tracking, it's essentially misplaced. As Emma described, the digital technology that's used in these reuse systems, like RFID, needs to be scanned by a specific reader in order to know where it is. This technology isn't GPS enabled. It isn't, continually identifying its location. The location is only registered when it's scanned. And of course, it's the movement of the containers rather than the people that's monitored, although obviously one could assume that containers don't return themselves. So the person is with the container when they bought and return it. But what we wondered was whether we need to be a bit more explicit and clarify the nature of the technology, how it works, that actually it's very similar to, when you pay with a credit card, near field communication, and that the information about the location is only provided when the specific reader is used. And we also thought it might be helpful to clarify the benefits of this sort of system. Why is the advantage of having a digital reuse system? Why do we want to include RFID tags? And the answer is that it means, there can be benefits for the system, that people can know where the containers are within the system, but also the benefits for the consumer. They can automatically be provided with, vouchers and incentives for returning. They can connect to an app and get information about the container, where it was previously, and so on. So we thought, well, let's have a look at, if we give people that information, does it allay concerns and increase willingness? I'm not going to give you the full set of results. I just want to show you the basic comparison between people's willingness to use the system when they're given information. So that's the bar on the right here, and when they're not given information. And what you can see is that there's no difference. People are generally pretty willing to engage with the system. So what's it, about 4 on a 4.3 or 4 on a 5-point scale, but there's no difference. If you give them information, they aren't any more willing to engage with the system. So I think this first set of studies suggested that people do have concerns about digital reuse systems, and information clarifying the exact nature of those systems doesn't really seem to increase people's willingness. So in our next set of studies, we wondered whether it might be better to focus on the benefits of reuse systems for the environment. So although evidence suggests that lots of people are aware of and worried about climate change, the environmental impact of choosing to purchase consumer products in reusable as opposed to single-use containers are not necessarily obvious. Indeed, as we've already mentioned in this webinar about life cycle analysis, and as you're going to learn from Ashik later in the webinar, these are sophisticated life cycle analyses are needed to estimate the relative impact of different product delivery systems, meaning that the average consumer is unlikely to, appreciate how their choices influence, for example, water consumption, energy consumption, CO2, and so on. But digital reuse systems have the potential to provide this information. If someone's using an app to check something out, the app knows what choice they've made, and if it's got a database based on the life cycle analysis that's been conducted, it could tell someone information in real time about their decisions. How much carbon dioxide has been saved by, for example, purchasing laundry detergent in a reusable bottle versus a single-use bottle. So in our next study, we asked consumers to imagine themselves using a refill system, this time for laundry detergent in the supermarket. We upped our game a bit in terms of getting them into it, and we put together a short video. So I'll just show you that. So the idea is that, as the video describes, that the person would imagine using this system and that the app would be able to give them information on the impact of their choices. So participants in our information conditions were presented with 4 metrics to highlight the environmental impact of their choices. Plastic consumption, so the number of bottles that they'd saved, the amount of energy that had been saved, water consumption, and CO2 equivalent. And they were either given that information with respect to, asked to imagine with respect to their actions, so far they've reused 10 bottles, and that would save, for example, 3 kilograms of CO2, or for the system as a whole. So imagine that the system's been used 2,000 times, which would save on average 6,000 kilograms of CO2. And they were given some comparisons of perhaps some more familiar metrics so that they can get a sense of how much that is. So 3 kilograms of CO2 equivalent to driving a car for approximately 7 miles. So does giving people that sort of information increase their willingness? Does it make them aware of the environmental impact of their choices and make them more willing to use these systems because they can benefit the environment? And the short answer is no. People were more aware of the environmental impact of reusing things, of reuse systems. And again, all of the participants were relatively willing to engage with the system. This time it's a 7-point scale. So, it's like just over 5.5 on a 7-point scale. But it doesn't increase willingness if you give them information on the personal impact, the environmental impact of their personal actions, or the environmental impact of the system as a whole. So where we've got to with our research is that the take-home message, I think, is that people are generally willing to engage. People are happy to give reuse systems a try. They do have some concerns, and if we try to address those potential concerns by giving people, clarifying the situation, giving people additional information and education, it doesn't really increase their willingness. And emphasizing the benefits of the system doesn't increase their willingness. So if people are willing to engage, but we see relatively low rates of uptake, I think enabling reuse at scale may not require changing minds. Education and information may not be the way forward. Rather, what we perhaps need to do is think about designing and providing systems that don't present barriers to willing consumers, don't make it difficult for people to do the things that they are willing to do. And interestingly, this is the same conclusion that was reached by a recent review of behaviour change interventions, which is across a really wide range of social, environmental, political and economic challenges. So specifically, having reviewed the evidence to date, Dolores Albarracin and her colleagues reached the conclusion that if you want to change people's behaviour, you should focus on interventions that enable individuals to circumvent obstacles to enacting desirable behaviours, rather than targeting salient but ineffective determinants of behaviour, such as knowledge and beliefs. So in other words, my conclusion is it's time to stop trying to educate and persuade people, just make it easier for people to do the things that they want to do and support them in doing that. So thank you very much for your attention. Very happy to take questions now or later on.
Brilliant. Thanks, Tom. So I think, as always, when we do work in terms of consumer engagement, it creates as many questions as answers, but that's fine. That's part of the gig. So the other questions that are relevant to this, one is from Adrian talking about, okay, so we've got an app and geolocating citizens, and was that anything that came up as part of the conversation? Are there any concerns around security and tracking?
Okay, yes, so people were concerned about the tracking element, not from a security perspective, although we didn't ask about that specifically. They felt that the tracking was intrusive. I think it sounds like Adrian makes a good point there, that although I've said, of course, the RFID tags aren't are only geolocated when they are scanned, the app that somebody's using, smartphones are GPS enabled, and I guess people could have concerns about somehow the app using the phone's tracking system or GPS. I think that in general, people are wary about these are still new technologies. And so I just think that's something to bear in mind when talking about these digital reuse systems.
Okay, and then correct me if I'm wrong, we've got an anonymous question here, but I think the general question is around engagement factors for consumers, and then also in terms of reuse and refill and the cost of goods, and whether there's additional cost, less cost. Are the consumers expecting a lower cost, maybe?
Sure. Yeah. So I think cost is one of the things that can present a barrier to people. And it's so, you might be willing to engage with the reuse system, and then you get to the point of buying it, and then you see that the reuse system, say, is 10% more expensive than the single-use system. That's going to stop you in your tracks. And it was interesting, there was a webinar earlier in the week by the Refill Coalition, who are doing trials in Aldi, and one of their key messages was that the reuse system would be the same price or cheaper than the single-use alternative. So we do need to be very conscious of choice and how that can certainly present a barrier to people, but it can also motivate if it's cheaper to use the reuse system.
Okay. Someone's just come back and they've clarified. So what I meant was, does reduction in cost increase willingness to engage in terms of factors? So
possibly, and the truth is we don't know the answer to that, and we're working on it. So one of the questions is, does a reduction in cost provide an incentive to people, and what effect do incentives have? So many of these reuse systems will employ some sort of financial or other incentive, maybe a penalty on to make the single-use alternative more expensive, or make the reuse system cheaper. And that price differential needs further research in exactly how much it needs to be, and how it can shift people. And just to say, it's not as obvious as you'd think. Someone said to me that, look at a penalty on a single use. So say it's 20p more to have a takeaway cup of coffee in a single-use cup. Some people view that as paying for the privilege, and that actually they're willing to pay it because they go, I'm paying for the convenience. So it can backfire, I think, sometimes.
Okay. We do have a few more questions, but I actually want to save them to the end because I think others in the group might have some views as well. So Tom, thank you very much for that really useful update on your work within Trace. Next, we move on to Sammy Latham and Bobby Ariamanesh from AMRC Cymru, who are going to give us an overview of the sorting demonstrator. Sammy, Bobby, over to you.
Hey, thanks, Stuart. Good morning, all. And just for those who aren't aware, the AMRC is part of the High Value Manufacturing Catapult, and we've been looking at sustainable packaging as a challenge for a number of years, and we're really pleased to be supporting the Trace project. So why look at automated sorting? That's the topic of what we're going to be looking at today. So already consumers in some urban areas are able to return to independently run shops to refill their containers with products like detergents, shampoos and food items. This method is widely accepted as eco-friendly and helping to reduce the volume of single-use plastics that end up in landfills. However, while this approach is beneficial for the environment, it does still have major challenges. So, for instance, it relies heavily on consumer participation and proper handling to ensure hygiene and product quality. So those are some things that my colleague Thomas has just been talking about. Additionally, the logistics of cleaning and reusing packaging can be cumbersome and overburdensome for the consumer to kind of take on that as responsibility. And another major challenge is insurance of end of life. So ensuring those reusable packaging, once they do reach the end of life, are recycled and not ending up in landfill. And as it is today, there's no assurance that it's actually happening. So understanding these challenges has helped us to appreciate the need for a more efficient and automated solution that manages that reusable packaging. So that brings us on to our topic we want to talk about, which is an innovative, automated solution that aims to create that streamlined sorting process. Okay, so this is our concept that makes disposing of reusable packaging as straightforward as normal recycling. So this is where it's a nice segue from where Thomas finished. This is what we're trying to achieve. So this idea revolves around the use of designated bins or potentially existing plastic recycling bins placed at convenient locations such as curbside, shops and workplaces. This way it makes it much easier for consumers to dispose of their reusable packaging without having to make any special trips or extra trips back to the shop to refill. Once collected, this packaging is sent to a materials recovery facility using existing infrastructures such as curbside collection and other already collected bins from businesses. At the material recovery facility, it's processed through a sorting machine equipped with advanced technology. This uses the tags to read the type of packaging and then sort it back into where it should go to the manufacturer. This level of precision ensures that all the packaging is sorted correctly, minimizing any cross-contamination. So in summary, this automated system we're proposing, it kind of addresses those key challenges I previously mentioned. So it simplifies the process for consumers, it ensures proper handling for hygiene concerns, and it's got ability to integrate into existing recycling infrastructure, and we're able to track where that item is and ensure that it gets reused, and when it reaches end of life, we can ensure it's being recycled as well. So this sounds like a great opportunity, but it does come with significant challenges to enable that sorting. So the first one is the rapid sorting of numerous packaging types with zero false positives. So in a material recovery facility, if you ever been to one, there's masses of materials going through extremely rapidly, and we need to accurately distinguish between all of them without any mistakes. Any false positives could contaminate the reuse stream and reduce the efficiency of the process. So achieving a zero false positive is critical for maintaining the integrity. Secondly, the challenge involves reading tags at a really rapid rate. And that's required for wide-scale adoption. If any of you are aware that we don't need to be too informed, but the volume of packaging runs into the hundreds of thousands per day. So if it's not able to scan and read quickly, then it would never have wide-scale adoption. Lastly, for the tags to be read and sorted efficiently, we need to control the flow. So ordinarily the flow is quite mixed, mingled, all messed around, so it'd be quite hard to pick out individual items. So we have to control that flow so we get a single stream of items that are able to be read and then able to be sorted efficiently. Okay. So this is a solution that we've been developing. So firstly, the location of the tags and conveyor is determined by proprietary reader logic and algorithms. So Sammy and some of the people at the AMRC team have been working on this one and the previous project with Pragmatic to develop some very clever techniques to be able to track items on the conveyor through once they've been read. This enables them to be known anywhere along the conveyor. We know the position of that tag. So once it reaches a certain point, we're able to use air jets to direct them into the correct bins based on what the information is held on the tag. This method ensures the sorting process is fast and efficient, and we do minimize any chance of errors because we're reading the tag and we know exactly where it is, and we can then sort it to the correct bin. Secondly, we've improved the efficiency of the tag reading protocols. This has helped us to achieve read rates that are over 10 times standard. So you'll all be aware of using your debit card to pay for items. There's a slight delay as you wait for that transaction to go through. Typically, it is between half a second and a second. If that was the case for our sorting machine, we would never have the throughput. So we've managed to reduce that to many orders of magnitude faster, so we can get a very high throughput. And finally, to control the flow of items, to get that single stream to enable reading and the direction of the air jets to sort them, we've included diverters to control the flow, an incline to pick up items from a hopper individually, And also we've got a drop mechanism which drops the items one at a time onto the reading area. So together we believe these solutions create a potentially scalable, efficient solution that can be used wide scale and adopted across MRFs alongside their existing systems to handle and sort reusable packaging. So now I'd like to pass you on to my colleague Sammy, who will provide an overview of the working demonstrator we've got in our workshop.
Morning all. Yeah, so this is this was the original design for the automated system. So this is a 3D model of what the conveyor actually looks like. You can see at the start we've got a hopper where we dump all our material in. Each of those has a test tag stuck to it. And then we have our incline conveyor, which has our mechanisms to control the object flow. And then these will drop in a controlled single file line into our reader area. And there we have an array of our readers on each side of the lane as well as underneath, so we get full coverage of the area. And then, like we said, for throughput, we take many reads, and because they happen essentially in an instant, that's able to send through to a main computer where we can compare our unique code from that tag to a database, see which material that item is of, or we can even sort by item type as well. And then we have an encoder to tell us the speed of the conveyor, and then we use that against the distance from the particular reader to the bin that item belongs in with the speed, and we calculate the time to set off a compressed air jet. And then any items, like we said, because we don't want to contaminate any items that aren't scanned, will just be sent off the end into a refuse bin. Next slide, please. So on the left, we have our items entering from our hopper and going up our incline conveyor. We found that one of the simplest ways we could to separate things into single file was using just a simple divider down the middle, and that would break up items side by side. And then you can see they come out relatively single file on the right at the end of the incline conveyor. And then that's the beginning of the reader area that you see there. Next slide, please. And then this is our array of readers on the left. So you can see there's 2 readers on each side. The 2 on the right are flipped, so you get a better height coverage as well. And then there's also 2 staggered underneath. And then each one of those we can calculate in our main computer program the distance from those readers to each bin. And then those are our items being sorted on the right. And as well, when we scan those tags, we also have the potential to push data to other programs or even a dashboard to say this was last scanned at this point or at this location, or we have this many items in our bin or being recycled in this time as well. Thank you for listening. Happy to answer any questions as well.
Lovely. Bobby, Sammy, thank you for that. We'll dive straight into a few questions for you. So even if the tag is facing the conveyor belt, are the sensors able to read the information from the tag?
Yeah, so on this left video here, you can see there's 2 readers on the left, 2 on the right, also staggered, and then there's also 2 underneath the actual conveyor, so reading up towards the belt, and they're also staggered side by side as well. So we're just ensuring maximum coverage in the reader area.
Okay, and in terms of the sorting system, is it able to differentiate between reusable and single use? This would enable consumers to return via existing recycling systems, maybe like curbside.
It differentiates between those that have a tag. Yeah, so anything that would be refuse or non-recyclable would just pass on to a refuse bin at the end. And that means we're not mis-scanning anything, well, mis-scanning any refuse and putting it into the same bin.
And we also have a question about what happens to items in the refuse collection. So I'm not sure whether that means, well, we'll answer both actually, because it's equally important. So items that get missed through this system, I'm guessing recycle, some of the MRF solutions that are used might help in terms of recirculation. What the question could also mean, what happens to items that are not put in the right bin and go into refuse? Could this kind of system apply to a residual sorting collection? What kind of contamination might it be able to handle before it doesn't spot the right products and sort them?
So there is, we've found that it's very good in terms of false positives, but there is the ability to put a secondary reader on the bin to ensure that anything that does go into the bin is the correct item. And then anything that's missed, depending on the scale of efficiency, it could go through the sorting machine twice to ensure everything has been read. And anything that not read goes through normal recycling streams at MRF. We expect that the items that would come would generally just be recyclable polymers separated at curbside or bins. So anything that's missed would go into normal recycling.
And also, do the readers pick up damaged items? I guess that means from a point of view of, can it differentiate between damaged and undamaged, which is less of an issue end of life, but certainly if we're trying to get back around the reuse system, is that a function that could be built into this at that stage, or would there have to be a post-sort assessment?
Yeah, it's a good question. We have it's something we considered. To put in a damage assessment at this stage would include an AI machine vision system that required to understand all the different types of packaging. So it would be better to place that once it's been sorted, and then you're only looking for the same type of packaging. So any damage would be quite obvious for the vision system and be more reliable.
And one more. So in terms of what you're actually scanning, is it RFID tag? You're not using hyperspectral vision systems with AI?
No, so we're concentrating on just a tag, but this can be coupled with near infrared or hyperspectral or shape recognition. It would work really well in conjunction with something else, but we wanted to concentrate just on the tag for now.
Perfect. Thank you both. That was a good update, and we shall move on. So, last but not least, pleased to introduce Ashik Ahmad, who is from Pragmatic, who's going to talk about environmental impact, LCA, and recyclability. Ashik, over to you.
Hi, good morning, everyone. I hope you can see my screen. Right. So yeah, in this section, we'll cover two aspects. One is on the LCA lifecycle analysis, and the other is recyclability. So on the LCA side, we have evaluated the environmental impacts of the EU system itself as a whole, and then we wanted to understand what additional footprint this adding an RFID tag to the reuse system brings to the overall reuse system. And on the recyclability part, we wanted to determine the recyclability of the RFID tags itself, and adding an additional component like an RFID to a plastic waste stream, whether if that is a cause of issue or anything. So those were the objectives of this section, and we studied these. So first of all, on the LCA, so for those who do not know what an LCA is, it is a powerful tool to evaluate the environmental impacts of a product, process, or a system. And it helps with informed decision making, and helps to identify hotspots, and it supports with waste minimization, resource conservation, and sustainable development initiatives. So for our study, we model the entire reuse system, right from raw material extraction until the end of life, as shown in the second half of the slide here. So it covered all the stages from raw material extraction, manufacturing, distribution networks, and washing, sorting, and end of life recycling. So the tool we used, there was a question about the tool as well. So the tool we used was Sima Pro, and basically we had to model it ourselves. Like the question was that whether if there is a suitable tool for doing this, but yeah, I don't think there is any specific tool that caters for reuse modeling. So you have to model yourself and then do the calculations yourself and then input it into the existing softwares that you have subscribed to. So we did that, and we assessed about 18 impact categories overall, and as shown in the figure. And the most significant ones were the global warming, terrestrial ecotoxicity, human toxicities, and fossil resource scarcity potential. So these were the some of the impact categories that had significant contributions, and the assessment was done for single-use cycle. So this is for per usage of a reusable package. So delving a bit deeper into one of the impact categories, which is global warming, it is one of the most common and most of interest. So looking at the figure here, you can see what are the stages and materials included in the life cycle analysis. So we had tray production, packaging production, crate and pallet, and we also had food production in that, and different types of transportations and end-of-life recycling. So considering the overall reuse system, I think the food production, the tomato here in this case is about 57% of the footprint. So we won't be able to do anything on that aspect. So looking beyond that, transportation was the second major contributor, so 27% of the footprint, and followed by sorting and washing stages, which were about 12%. So these are the hotspots that we were able to identify through this assessment. And like say, for instance, if you want to further optimize the reuse system in future, we could probably look into reducing the transportation distances, because in this case, we were having about over 100 kilometers of transportation for each leg. So maybe having more distribution centers or more facilities open along once it matures would help us to like kind of minimize the footprint from that front, and also like shifting to electrified vehicles or networks to distribute these materials would be useful as well. And after that, probably looking into sorting and washing stages, maybe shifting to renewable energies for these stages would be helpful as well. And if you look at the contribution of the RFID tag, it was less than 1% of the overall footprint. So effectively, like if adding an RFID tag to this reuse system could potentially improve the efficiency in terms of collection, tracking, and logistics of the reuse system itself, then probably it is very much worthwhile to add that, so that the overall improvement in the efficiency could offset the footprint that brings with the RFID tag. And moving on, the second half of the study was on the recycling. And before we went into the recycling, we surveyed different types of recycling technologies that were available for plastics. And the major groups were mechanical recycling, thermochemical, and chemical recycling. So within that, we looked at whether if there is pre-treatment needed, and some of them required sorting and washing, and some of them didn't. And we also looked into the technology readiness level, so that to understand whether if it can be right away applied to the packaging. So coming to the recyclability of the RFID tags, so there are two scenarios for the recycling of the RFID tags itself. So one is you detach that from the packaging. So what happens is that you could use a simple pre-treatment like UV treatment or caustic washing or something. It depends on the adhesive that we use for the attaching the tags onto the packaging. So that could be customized, and that could help in the detachment process. So if that is the case, then probably we could be able to recycle the tags either through chemical or thermochemical methods. However, this is what of the existing technology. So if there is going to be volume of RFID tags in future, then probably it is worthwhile to develop an own recycling methodology for RFID tags, so that you get more resource out of this rather than fitting into the existing recycling options. And the second option here is recycling along with the packaging. So here we have different types of packaging materials, and the tags are still intact with these packaging. So what happens in this case is that it can go through mechanical recycling, but then the product would be downgraded because there'll be particles of RFID within that. And this is kind of considered open loop mechanical recycling, because there are bound to be some impurities in the system. In the closed loop, the RFID tags needs to be detached. So when you go for an open loop mechanical recycling, the end product is certainly downgraded, and there might be a bit of challenges in food contact applications afterwards. But then, other than that, if we are looking for chemical or thermochemical recycling, then probably we don't see any issues with that. And yeah, so these are the major learnings from this study. So from the life cycle analysis perspective, we were able to evaluate the footprint of the entire system, which was about 0.27 kg CO2 per reuse cycle. And of that, the RFID contributed less than 1%. So it is worthwhile to kind of add this technology onto the system, so that it adds more value overall. And on the recyclability, we don't see any challenges in the recycling process itself. It didn't get affected. However, the end product might be downgraded, and the RFID tags can be recycled chemically or thermochemically at present, but then developing a dedicated technology would be worthwhile going forward. And if I have time, I wanted to show a snapshot of our previous work. So this work was conducted in collaboration with the University of Manchester for a previous project, and we did do proof of concept experimental evaluation of what I shared earlier. So we used RFID tags and mixed it with plastic pellets, and we did do the mechanical recycling, extrusion, and we were able to produce the pellets. And when we analyzed the pellets, there were definitely tiny fragments of the antenna material there. So that is something that we were able to identify, and we did publish a research paper out of this work. And also we also did a chemical depolymerization experiment where we attached tags onto the single-use bottles, and we were able to chemically treat it and extract the end product out of it. So the process itself wasn't affected. However, the end product needs to be considered when it comes to mechanical recycling. The rest of the recycling methods shouldn't be an issue. Thank you. Happy to take any questions.
Brilliant, thank you for that. And I think it's always interesting when we look at LCAs, something we all know, when it comes to reviewing impacts, the stuff that's in the packaging always has significantly higher impacts than the packaging itself. There have been a couple of questions that have come up. So in terms of the LCA, how many reuses were assumed as part of the study?
That's a good question. So we assumed 10 reuses. The scope of the work wasn't to compare with the single use, so we didn't do that. But then as a personal exploration, we did that, and the break-even point between single use and reuse is about 10 to 11 reuses. So for this study, we assumed 10 reuses.
Lovely, thank you. A couple of other questions have disappeared. I think, as with LCA, it can be quite complicated, and I suspect we'd need to look into more detail, and people have other questions. So thank you so much for that, Ashik. I'd like to invite all of the speakers to turn the cameras back on and the sound, and we'll try and pick off some of the other questions in the next 10 minutes or so for the end of the webinar. So Open question, because I'm not sure, I guess pragmatic, but what are the RFID tags made of?
I can take that. So in general, I suppose you have a PET backing, and then the antenna is aluminium, and then for our technology, the chip itself is a bit different. So that is a polyamide substrate, and then semiconductor on top. Typically, that would be a silicon chip for kind of your more everyday kind of RFID chips, but ours are a little bit different.
Lovely, thank you. And by the way, I know the speakers have been responding to questions in the background as well. So there's one or two of those that I think is worth revisiting. So sticking with you, Emma, I know one of the questions was around RFID in terms of other approaches like QR codes and what's most cost effective.
Yeah, I mean, I think that really depends on what you're looking to do. I guess what I was trying to kind of get across in my slide that I had where we compared was, you know, QR codes, it can be great if what you want to do is essentially the kind of consumer angle, consumers know how to scan those. But if, as we're looking at some of these kind of broader benefits across the value chain, more of that automation side, then that's where we see the RFID or NFC really having value. So I really think it's kind of, it depends on the situation kind of answer, I would say.
And actually, I know a couple of the questions that have come up this morning have been around, did we know about a certain platform or other technologies? And I guess from the group, it's quite interesting to see things are moving quickly in this space in terms of competition versus cooperation versus alignment. And how the different partners in this project see that coming through, both in terms of technology, solutions, and the range of apps and this consumer engagement pieces. So, you know, where are we heading with this? And can some of the learnings from our project actually be used with others to cooperate moving forward? So, Emma, I can see you.
Sure. I mean, yeah, absolutely. I think really what we want to do is kind of share learnings, right? That's the kind of the whole point of today, and also of having these types of innovation kind of partnerships. So we've got a number of things that we've published, I suppose, as part of the work. So Tom's published a number of studies, Ashik also. So yeah, there is this kind of, we are looking also to how we can disseminate further as well. But certainly kind of going forward, I think we would like to build on this and kind of continue. So happy to obviously be contacted by anybody that's interested afterwards.
And Tom, I know there are a couple of questions that we were leaving to the end around the consumer again, economic incentives playing a part in behaviour change. If so, are you engaging with DEFRA and the DRS scheme, for example, incentivizing reuse rather than just recycling? So if you could elaborate a bit on what you'd said in the chat, that would be good.
Yeah, sure. I mean, we are talking to DEFRA, but I think the broader question is how do penalties and incentives influence behaviour? And I think there's a number of interesting questions there, and I don't think we've got the answers to them yet, despite the fact that almost all reuse schemes employ some form of incentive or some form of penalty, and that might be a delayed penalty, or a deposit that you pay, or an upfront penalty like a deposit which is then returned later, an immediate benefit like points on a card, or an immediate discount on your purchase, and immediate penalties, all sorts of interesting things. And I think that a lot of these decisions are being made in the absence of very clear evidence on what shifts people's behaviour. So I know there have been consultations around similar things. So, for example, the carrier bag charge, what was it? It was 5p and then it went to 10p. And there was a whole consultation about that. And I don't think the evidence, the difference between 5 and 10p was particularly clear. And similarly, I think a lot of organisations are making decisions in the absence of evidence. The University of Sheffield runs a reuse scheme. We've just changed our charge on single-use cups from 20p to 30p. And I don't know the basis for that decision. So we're doing a review, and I've put a link in. If you look through the answered questions, there's a link to an open science framework pre-registration for a review. We're really looking for anyone who's got evidence on uptake of a reuse system when an incentive's been in place, and ideally, the same system when it's not been in place. You know, what effect has that had? But we're really interested in any sort of data, so do get in touch if you've got things that you think might be suitable for that review.
And Tom, I think there are a few projects we're aware of maybe in that space, so you know, we can take that offline as well. So just following up on that, and again, it's back to social norming. There's a gap between knowing what the right thing to do is and actually wanting to do it, breaking and resetting the habit. So you actually say then the biggest challenge from the work you've done in that space. So if you had to pick one, is there a certain demographic? Is there a certain type of system that's just always going to be a challenge to get across and become a, as I said, for many, not just for the few of those consumers who are environmentally switched on?
Yeah, I think the bit of that question that I pick up on is habits. I think that's our challenge, but maybe seeing it as an opportunity. So, you know, I don't think it's about wanting to do the right thing. I think many people want to do the right thing. They get it now. I'm not saying everybody gets it, but I don't think that should be the focus of our efforts. I think we'd be much better focusing on, well, look, people have got habits. We've been throwing things away for years. So what are we going to do? Can we design systems where it's very, very similar, that actually the bin where it's thrown away that's where you put the reusable items as well, and it's somehow sorted. You know, working with people's habits rather than against people's habits would be one way to do it, because quite right, breaking habits is very challenging.
So one for all of the speakers, we've been talking about practicalities and technology and consumers, and where we are today is policy has a role to play, and it's come up in some of the questions. So in terms of, will revised extended producer responsibility support and incentivize reuse systems? And I see we've got Andy from Welsh Government on today, and he said, you know, certainly in Wales they're keen to promote it. But I guess the open question is, there is a new UK government who's already making commitments to zero waste and circular economy, but are we ever going to get as far as we need to without stronger UK policy in the reuse space? And I'll leave that open for anybody to come back on.
I'll start. Like, in a short answer is definitely no, that won't happen without the policy. Reusable systems as such, they prove their viability and economically and environmentally through the modeling. They definitely work and make sense. However, when they're competing with the established single-use systems, which often stimulated and supported by legislation, it's very hard to make this transition and reach the required scale. So without the policy supporting, especially the transition, it would be very hard to make this change. How this policy will look like, there's obviously different options we can ask, we can expect. This can be something similar to the plastic packaging waste regulation, where there is reuse targets. It's maybe not ideal, but that's one of the way to approach it. Can extend producer responsibility move the change? Possibly, depending on what form the regulation is presenting. So in short, yes, we definitely need financial incentives from the government to support the transition, need the policy. Which one is ideal? That's open for discussion.
And Irina, just to follow up, a question from Luell then builds on that to say, how can we get businesses to look at the longer term rather than short term in terms of the payback of using reuse systems? Do you see that as a practical thing, a policy thing, or both?
I think that what policy can help with a longer term commitment and longer term kind of investment is the creation of this sense of that reuse is inevitable. So that will happen, though, because I think now we all like, oh, that's a good thing to do. Everyone is trying to do it. But as soon as the policy and government is clear, that's going to be part of the life, then everyone will be happy to be on board.
Okay. We're coming to the end of the webinar, 10 seconds each. We've not prepped this question. For you and your organisation in the reuse space and the learnings from the project, what are you going to be doing next? So I'll come to Emma first.
Oh, 10 seconds. I mean, I suppose we are continuing to look at this area. As the project closes, we'd be definitely interested to have any kind of additional collaboration, to talk to anybody who's interested in this. So I'm going to just pitch for anybody to contact us who would like to kind of work together on this angle. Yeah.
Thank you. Irina?
Yeah, we are looking to develop the reusable packaging design guidance further to apply to the changing environment and more looking at recyclability of reusable packaging as well.
Yeah, I really want to develop the evidence base around the effect of incentives and penalties. And we're doing that as part of a European project on reuse called BuddyPack. So very happy to talk to people about that.
Bobby and Sammy?
Thanks, Kurt. So we're really interested in understanding the NFC technology further, and also where else it could be applied, not just in this sector, but for other manufacturing sectors. There's a lot of opportunity for sustainability as well.
And Ashik?
Sure, thank you. For us, we currently looked into one of the food packaging applications, so we'll kind of look into other applications and see where we can fit, particularly the RFID tags from Pragmatic, because inherently we have a lower footprint, so we might be able to leverage this for different applications and kind of expand the use applications.
Okay.
Thank you.
So that's it. We're out of time. Thank you all for your questions, comments in the chat. We at the Trace team will pick that up and capture all of it for review. There's a lot more to unpack beyond the webinar, of course. There's quite a few learnings and challenges there that can be applied and accessed by a number of technologies and reuse solution development, so that's all good. If you want to hear more about reuse and other related topics, you'll meet many of the players as well in the reuse and resource efficiency space. Please do look up the RECOUP conference on the website. That's 26th of September. And finally, and most importantly, thank you to all of the speakers for answering all the questions, sharing the information, and keeping to time. All the contributions were fantastic, and I wish you and everybody on the webinar all the best on your reuse journeys. Thank you, and have a great rest of your day.
Thank you, Stuart. Bye, everybody.
Thank you.
Thank you.